can say a glass rod, you can say a stirrer. So that's a glass rod or a stirrer. Next, what is used to add strontium carbonate to the acid? Strontium carbonate is solid. What we can use to add solid to a mixture or a solution? Which piece of apparatus is used to add solid? So if you want to add a solid, we use a spatula. Name the dilute acid used. If you are preparing strontium nitrate, which acid should be used to produce a nitrate salt? If you want to produce a nitrate salt, which acid must be used here? If you want to produce yeah, we should use a nitric acid. If we want to prepare a sulfate salt, then sulfuric acid. And if you are producing a chloride salt, then hydrochloric acid. Give one expected observation. What is the expected observation when metal carbonate is added to acid? One only you have to write. One expected observation. Fizz, bubbles, effervescence. Because when acid react with metal carbonate, this gives salt and water carbon dioxide. So that's why you will see bubbles. Why heat is not necessary in stage 2? Why we don't have to supply heat energy in stage 2, just only stir? So normally heat is done or heat is supplied for reaction in which the react does not happen or occur or very slow at room temperature. So why we are not heating this? Because the reaction can occur at so if the reaction can occur fast at room temperature or faster at room temperature, we don't have to supply heat energy. Which of these reactant in excess, and explain your answer? We have a nitric acid and we are adding strontium carbonate. Which one is in excess? More than enough for this reaction. A solid strontium carbonate is added to nitric acid. You find some of the solid is left. The unreacted solid is there. So which reactant is in excess or more than enough? So the solid strontium carbonate is in excess. Otherwise, if strontium carbonate was a limiting, then it should be completely dissolved and no solid left behind. So the question is, which of the reactant is in excess or which of the reactant is more than enough? The answer is solid strontium carbonate, because it is left behind. After the reaction in a beaker, that's why it is more than enough. Describe how a crystals of strontium nitrate could be obtained from a mixture in stage 3. So in stage 3, first we have unreacted solid. So first what we have to do, we have to remove this unreacted solid. So filter to remove unreacted solid. That is one thing. Then what we will do, we will heat and till the point of crystallization. Heat and concentrate the solution till the point of crystallization. And then we will cool down and filter again to remove strontium nitrate from the solution. This is how we obtain a soluble salt from the mixture or the solution. The second part, a student investigated a reaction between the aqueous sodium thiosulfate and two different aqueous solutions of potassium iodide labeled C and D. Two experiments were carried out. A burette was filled with aqueous sodium thiosulfate. Initial reading of the burette was recorded, and using a measuring cylinder, 20 cm cube of solution C was poured into a conical flask. 10 cm cube of dilute sulfuric acid and 1 gram of potassium iodide was added to a flask to form a solution. The flasks were swelled to mix the content. The advantage of a conical flask, you can easily swell the mixture. Otherwise, if you are using a beaker, if you try to swell, then the solution will come out. That's the advantage of a conical flask. Small mouth, so the liquid cannot come out when we are swelling the mixture. Aqueous sodium thiosulfate was slowly added to from the burette until the color, when the content of the flask turned pale yellow, light yellow, then a starch is added and the solution turned blue black. The purpose of the starch is used as an indicator for iodine reactions, because in the presence of iodine, starch is blue black. If iodine is not there, it will be colorless. Then in the question, use a burette diagram to record the reading in the table and complete. What is the initial reading, the starting reading of the burette? What is the initial reading? What is this value? So initial reading is 4.1. What about the final value? The final reading? That is 38.3. When you take the difference, that will be the 38.3 minus 4.1. The difference will be 34.2. So first experiment, 34.2 cm cube is there of sodium thiosulfate. The conical flask was emptied, rinsed with the distilled water. Why we rinse with the distilled water? To remove any trace of solution present. Then experiment 1 was repeated using solution D instead of C. The initial burette reading, what is the initial burette reading here? With D, 3.7. And what is the final? What is the final reading? 20.8. And what is the difference? 17.1 will be the difference. So in the question, for D we need 17.1 cm cube of thiosulfate, but for C we need 34.2 2 cm cube of thiosulfate. So example, if we have two conical flasks which are filled with equal amount of C and D, 20 cm cube of C and 20 cm cube of D, and another conical flask we have 20 cm cube of solution D. Then we fill the burette with same amount of thiosulfate, but in the first reaction we need 34.2 cm cube of thiosulfate. In the second reaction we only need 17.1 cm cube of thiosulfate for a complete reaction. The question is, which solution, C or D, is more concentrated, which is having more particles in it, which solution is having a higher concentration, C or D? Which solution required higher concentration or having a higher concentration? They're asking for C and D. They're not same thiosulfate is there, but the first experiment you only need 34.2, the second experiment 17.1. So which is more concentrated solution in the conical flask? In the conical flask they're asking. Thiosulfate is the same. So which solution is more concentrated? C is more concentrated. And D is having a less concentration. Why? Because you need greater amount of thiosulfate for complete reaction with C, and you need a small amount of thiosulfate for complete reaction with D. So which solution of or C or D is more concentrated or having more particle? So C is having more particle. That's why you need greater amount of thiosulfate for the reaction. So the second part, which solution of potassium iodide solution is in a conical flask, is more concentrated, and explain your answer. So which is more concentrated? C is more concentrated because it needs greater amount of thiosulfate for a complete reaction. So when you are comparing the particles, you have C, you have solution C, and you have solution D. You are adding a thiosulfate to this. For solution C required 34 cm cube or 34.2 cm cube of thiosulfate, and solution D only required 17.1 cm cube of same thiosulfate. So which solution is having more particles, C or D? So it shows that because you need more amount of thiosulfate, so it shows that C is having more particles as compared to D. So C is more concentrated than D. Is it clear? then how many times more concentrated is this solution compare of potassium iodide? So when you are comparing, for C it required 34.2 cm cube of thiosulfate, but for D it only required 17.1 cm cube. So when you compare the concentration, it means the concentration of C is twice or double compared to D. So C is more concentrated and it required, so it required greater amount or double amount of thiosulfate. Predict the volume of thiosulfate that would react completely with 30 cm cube of solution D. Look, how much D you took in experiment 2? We took the same amount, like we took 20 cm cube of C, and we repeat the experiment, we took 20 cm cube of D. So this 20 cm cube of D, this is a conical flask, and first we took 20 cm cube of D. From the burette, how much thiosulfate is needed? 17.1 cm cube. Now the question is, if I repeat the experiment with 30 cm cube, how much thiosulfate is needed? So what you can do, you can simply use a ratio, like if 30 cm cube of D, if 20 cm cube of D required 17.1 cm cube for a reaction. So if 30 cm cube of D, how much thiosulfate is required from the burette? X. Cross multiply. So 17.1 multiplied by 30 divided by 2. What's the answer? 25.6. So how much? So we need 25 point. So you have to show this working here. That's why it's of 2 marks. 1 mark is for showing the working, and then the second one is for your answer. 25.65. So you, because a burette can read about 0.1 cm cube, that's why it will be 25.6 is acceptable. 7 is also acceptable if you're rounding off. State 2 sources of error in the experiment. What are the sources of error in this experiment? You are using, so sources of errors, you can mention a parallax error, look perpendicular, or you can mention use a measuring cylinder. Using of a measuring cylinder, we should use a burette or a pipette for that, or carrying out experiment once only, like we're not doing experiment 2 times or 3 times, only one time we did for C and one time we did for D. That is not an accurate way. So we should repeat the experiment, carry out experiment many times, or maybe adding too much, like we are adding too much liquid from the burette, or quickly adding the liquid from the burette. So we should add gradually. That can lead to that can improve the result. So 2 sources of errors: parallax error, and how you can improve that, look perpendicular. You can mention using a measuring cylinder. So we should use a burette for that as well. And no repetition. accuracy of experiment is affected by repeating the experiment. It will become more accurate as we repeat the procedure. Question 3. Two solids E and F were analyzed. This is related to identification of the salt. Solid F is potassium iodide. So they give you the identity of solid F, it's potassium iodide. And E, they did not give you anything. Appearance of solid E is green solid. So if it's a green solid, that gives you an idea that it is a transition element. Green does not give an idea chromium, it gives idea transition. Green precipitate with sodium hydroxide give an idea that iron or chromium can be there. You don't have to the green color, even copper carbonate is also green in color. So color green does not mean that specific element. It gives an idea that there is a transition element is there. The color of the precipitate when you add sodium hydroxide or aqueous ammonia, that confirms the presence of the metal ion. A solid he was heated gently, then strongly, and solid turned black. So basically what happened, if you remember copper carbonate, which is green in color, when we start heat it, it becomes copper oxide and carbon dioxide to turn black. So this black solid is copper oxide now. Then test 2, dilute sulfuric acid was added to solid E. When we add an acid, rapid effervescence and lime water turned milky. So that gives an idea that E contain a carbonate ion. An excess of aqueous ammonia is added, blue precipitate form a dark blue solution. So that confirmed copper ion is there. Copper 2. Flame test was carried out. It's blue and green color flame. That is a confirmation for copper flame. Copper flame is blue-green in color. Sorry. Test 1. Test 1 state that the solid should be heated gently then strongly. Explain in terms of safety why it is necessary to heat gently and after that strongly. What is the reason for that? Why not directly heat it strongly? You should relate with the experimental safety. So what are the dangers? Look, what is the purpose? Why you're not heating it strongly? For example, you have a test tube. This test tube contains a solid. When you supply heat energy, if you heat it strongly, the test tube might crack. So, but when you are heating it gently, the test tube become warm and then you heat it strongly. Now the test tube will not have a rapid change in temperature. That is why it will reduce the chance of cracking of the test tube or splitting of the solid. If you directly heat it, first you should make it warm and then heat it strongly. If you directly, like example, if you take a thermometer and place thermometer directly into a boiling water, what will happen? The thermometer glass will break. So same thing happen here. If you place directly into or directly heat it strongly, the test tube or the glass might break, or the test tube might break or crack, or the solid can also spit out from the tube or come out from the tube. Safety precaution you have to mention. So the next part, identify the gas given off in test 2. Which gas is given off here in test 2? carbon dioxide is there. Identify solid E. What is solid E? So it is copper carbonate or copper 2 carbonate. When you mention a transition element, always mention their state as well. Copper, in a Roman, you can write 2 and carbonate. There is copper 1 as well, but you are learning only copper 2, not copper 1. Copper is having a variable oxidation state, that's why it is also a transition element. Test on solid F. Solid F is potassium iodide. Describe the appearance of solid F. How it will look like. It's of 2 mark. 1 mark is for mentioning copper, 1 mark is for mentioning carbonate. The solid E was copper 2 carbonate. 1 is for copper, 1 is for carbonate. A solid, not a solution. Solution can be colorless. You don't say solid is colorless. Solid can be transparent or white. But group 1, 2, 3, they all are white solid. Distilled water was added to solid F in a test tube shaken to dissolve solid F. To the first portion of a solution, excess of sodium hydroxide is added. If we add sodium hydroxide, group 1 does not form a no reaction, no visible change. To the second portion, we add a nitric acid followed by silver nitrate. It's a potassium or contain an iodide ion. What we'll observe? Iodide ion is there, and this is a test for silver nitric acid followed by silver nitrate. This is a test for halide. What we'll observe? We'll observe yellow PPT or yellow precipitate. Now you should memorize this table. That is very important. You should know the observations and the test. A flame test is carried out on F. What is the flame color of potassium when we burn a potassium compound? That is lilac. Then how would you carry out a flame test? Procedure for flame test: take a nichrome wire, place it on the hot flame, take a nichrome wire dipped in concentrated HCl and place above the hot flame or blue part of the flame. And place above the hottest part of the flame, or the blue region is the hottest part of the flame. Then this is the last question. A sample of a furniture cleaner contains aqueous sodium chloride, aqueous ammonia and sand. Give a test to show the presence of ammonia. How we can test the ammonia? Check the presence of ammonia. The test for ammonia, it is a damp red litmus. Ammonia can react with sodium hydroxide, but test for ammonia, it's ammonia gas. If it says ammonia mine, we add sodium hydroxide and heat. But if we want to check the ammonia, which is a gas, then red litmus will turn blue. Plan investigation to obtain a sample of pure water from the mixture. So if we want to obtain a pure water from the mixture, we will heat. Basically, we'll use a fractional distillation or simple distillation. You can also. So we'll use distillation. We'll heat and evaporate the water. Then we will condense. By condenser. A pure scent from the mixture. If you want to obtain a pure scent from this mixture, so what we can do, we can use a decanting or filtration. So we will use filtration. Then how you'll do filtration? Pass the solution through filter paper. Sand left behind as residue. Then wash with distilled water. And dry with tissue or filter paper you can use. Is it clear? This how to separate the water from the mixture. Sorry, sand from the mixture and pure water from the mixture. So this was a paper 6 of May-June 2017, variant 1. Any other doubt or a question?